welcome back to the channel. So here we are at the end part of this chapter, carbon and its compound. So this is going to be part 4 of this chapter. We have completed 3 parts of this chapter, carbon and its compounds, wherein I have discussed each and every topics from this chapter. If you have any doubts regarding any of the topic, you can go through the past videos. I have made part 1, part 2, part 3 totally based on carbon and its compounds. So just please check if you haven't already. So yeah, let's start with the part 4 today. So in this part 4, we are going to discuss about soaps and detergents, about their structure, about their properties, how do they react and how do they help us, what are their uses and how the soaps differ from the detergents. And then all these are followed by the NCERT exercise solutions. We're going to discuss some of the NCERT exercises and try to solve them together. Alright, so I would suggest that keep your notebooks and pen ready with you. We are going to do it together. Already in the part 3 section, we have discussed about the soaps. If you remember, the major reaction which we have discussed about is known as saponification. First was about the reaction of ester. Okay, so we are going to discuss a bit more because it is related to the structure of the soap. Formation of soap is related to the saponification reactions. So we will today discuss more about it and let's learn more about soaps. Alright, so soaps, my dear students, soaps is the hydrocarbon which is saturated. So it is bit eco-friendly to the environment, okay, because it is saturated hydrocarbon. It can dissolve easily in the earth, okay, so it's biodegradable, okay, so that's why soaps are being used more and more. All right, so first we will consider the structure of soaps. Where does this how can we form the soaps, right? Obviously soaps are being formed from in the laboratory. So what are the reactions which goes at backhand? We are going to learn about it. So soaps are salts of fatty acids. They are produced by the chemical reaction known as saponification, which occurs between the fats or oils and a strong base, typically sodium hydroxide or potassium hydroxide. Alright, so what was the saponification reaction? We are going to see. So the reaction of soap formation is saponification. In this process, fats or oils which are made of long chain triglycerides. So you remember these glycerides are none other than but the esters. So when we react the esters with the carboxylic acids or the chain of carboxylic acids, we can have the plus we should have the sodium with us, all right, because we already know that soap is nothing but sodium stearate, okay. So this will form when esters will react with the carboxylic acid having the sodium or you can say potassium in it. So you will get the long chains of carboxylic acid which may be stearate, palmitic acid as well. So these two are the acid chains which are present inside the formation of soap, okay. And also you will get little bit of glycerol obviously because of esters, because there are triglycerides, okay. So this was a saponification reactions where the esters get react with the carboxylic acids, plus there should be sodium or potassium at their end chain. The carboxylic chains must be end with sodium or potassium, and then you get the stearate, sodium stearate, and the glycerol, that is your soap. So now we will consider about the soap structure. How does the soap structures look like? So the soap structure has 2 parts, hydrophilic head and the hydrophobic tail. So what does it mean? Hydrophilic means water attracting chain, water attracting head, okay, which like water, which can easily get dissolved inside the water. And hydrophobic tail is like water retaining or water recessive. So as you can see on the screen as well, this is a soap structure. So basically this circle is hydrophilic end or hydrophilic head, and this is hydrophobic end. So what happens, as you can see, this head is actually the chain of carboxylic acid, you know, okay, and plus on its head there is some ionic group. It can be sodium or it can be potassium. plus it has a long chain. Now this long chain represents the hydrocarbon chain of CH bonds. So this is the structure of whole soap. Okay. So this tail is actually the hydrophobic part, which is like water repelling. It will not go inside the water. Okay, hydrophobic. And this part is known as the head part is the hydrophilic part, which is like attracting the water. Okay. So now we will see what are the functions of these two parts. Hydrophilic head of soap molecule is hydrophilic, water attracting, which is made up of carboxylate group, you can see, attached to the sodium. So these are certain ionic heads, obviously it's a saturated hydrocarbon which is present inside the organic chemistry, and these ionic which I'm talking about comes under inorganic chemistry. So this inorganic, there is a you can say there is a mix and match of inorganic and organic chemistry for the formation of the soaps. As you can see, the head side there are certain ions. There is a chain of carboxylic acid and there is a potassium and the sodium ion as well, which are having the plus charge on it, and the carboxylic is having the negative charge on it. So they basically are considered as the ionic head, or you can say the inorganic heads. And this chain, the tail, which is hydrophobic part, is a CH bonds chain. So the hydrophilic parts interacts with the water molecule. So always remember, the chain, the head which is present inside the soap is going to attract with the water. The tail of the soap molecule is hydrophobic, water repelling, and consists of long hydrocarbon chain made up of carbon and hydrogen atoms. So it's an organic chemistry. This tail binds to grease and oil particles which are hydrophobic. Now where this grease and oil are coming? Now we have just now studied that they are the formation by the esters, means they are triglyceride. They are having the glycerol. So from where this grease and oils are coming? So basically, grease and oils represent or refers to the dirt particles. So majorly the dirt particles are kind of oily things, right? So for that, to removing that, we need soaps, right? So in this way, hydrophobic and hydrophilic part will work. All right. So you can see this is the ethanoic acid, and first we will see the formation of ester. Now when the ester goes through sodium hydroxide, then you can see there is an alcohol formation, and then this is actually the stearate, which is the soap. Okay, actually we need this one. Okay, so this is the part of soap which is formed. Now what is this part? What is this figure known as? Actually these figure are known as micelle. So whenever we use the soap in order to remove the dirt particle which is greasy or oily, soap has a capability that it forms certain micelle structure. Now what does this micelle structure do? Now, and in this micelle structure, hydrophilic and hydrophobic part comes into action. Now what happened? You can see this is the hydrophilic part where this is the ionic bonding. This circle one is the carboxylic chain COOH, which is negative, and this is the ionic. This is the ionic part. This will dissolve inside the water, and this chain which is CH bond chain comes at the dirt particle. Okay, so it will get mixed up with the dirt particle. This part, this sodium and this ionic part is going to help in forming the emulsion. Okay, now what does this emulsion means? Whenever the hydrophilic part get dissolved with get mixed up with the dirt, so all the leftover dirt get again dissolved with the sodium ions. Okay, so now the dirt is present inside the water. So emulsion is like the sodium ions or the potassium ions helps in forming the emulsion. That means it helps in dissolving the dirt or the greasy part inside the water, so that cloth or anything which is stained get rid of that greasy or oily dust particle or dirt particle. You got it right? So in this way, the whole hydrophobic and hydrophilic parts of the soap comes into action in order to get the cloth or anything which is stained to get rid of that. okay, of that dirt particle. Or apart from this, we are also having the steps. How does a soap comes into action? So soap molecules surround the dirt and oil. The hydrophobic tail of the soap molecules attaches to the grease or oil molecules which are hydrophobic, while the hydrophilic head faces outwards towards the water. Formation of micelles. The soap molecules arrange themselves into sphere structures called micelle. In a micelle, the hydrophobic tails form the inner core, trapping the grease and oil, while the hydrophilic heads are on the outer surface interacting with water, as I have already told you. Washing away the dirt. So, for washing away the dirt, here the emulsion is formed, right? So, when you rinse the soap, the micelles which now contain the dirt and oil are washed away because the hydrophilic heads are soluble in water and the hydrophobic tails are trapped inside away from the water. So, this is the whole part which I have already told you in this sector. Soap is a saturated hydrocarbon. So there are some properties of this saturated hydrocarbon which we will learn. So see, this saturated hydrocarbons is solubility, means it can easily dissolve inside the water, so it's high, which helps in emulsifying the oil and fats and making them easier to remove the stain or remove the stain inside the water. Then effectiveness in soft water. So soap, which can easily dissolve in water, comes into action more easily when the water is soft, because in the soft water there is the possibility that certain magnesium and potassium ions are not present there, whereas in the hard water there are certain ions like magnesium and calcium and their concentration is high in hard water. So soap doesn't work properly inside the hard water. So detergents are considered as unsaturated or saturated hydrocarbons. It means they are not easily get dissolved inside the environment, and that is why they are non-biodegradable. Okay, they are non-biodegradable and less friendly to the nature. Okay, reaction type saponification, and they are formed by the chemical synthesis. And then their solubility, if we talk about solubility, so detergents can work in soft and hard water both, but soaps cannot work in the hard water. That is why they form scum. Okay, scum, you already know this. This is considered as scum. In Hindi we call it as jhag. Okay, so scum. Then environmental impact, it's non-biodegradable. That is why it do give or have a higher environmental impact. And okay, now we are going to do NCERT exercises. Question number 1, ethane with the molecular formula C2H6 has how many bonds? 7 covalent bonds. Butanol is a 4 carbon compound with the functional group ketone. We already know it's a ketone group. While cooking, if the bottom of the vessel is getting blackened, it means it's incomplete combustion is happening, right? Incomplete combustion is happening. So option B is the correct one. Now we will see the question number 4. Alright, so explain the nature of the covalent bond using the bond formation in CH3Cl. So it is a covalent bond. Already we have discussed the whole example in part 1 section. Please go through part 1 section, you will get the answer, or you already know the answer if you are following me from the part 1 of the same chapter. Now the fifth question, you will see the fifth question. Draw the electron dot structures for ethanoic acid. So this is the answer. This is the ethanoic acid answer, and then H2S is this one. This is the propanol, and then here you can draw the F2 as well, because you already know, you always remember that it depends upon the atomic number. Okay? So electronic configuration is 7. So you can easily draw it. It's 2F, so it means there is a 7 one. It needs only 1, 2, 3, 4, 5, 6. It needs only 1 to complete it. So this is the electron dot structure for F2. When we talk about the homologous series, so it's like methane, ethane and propane is a series of homologous series, which does not change the chemical properties, but physical properties changes, obviously because atomic masses, the size is being increased. How can ethanol and ethanoic acid be differentiated? By if the major test is sodium hydrogen carbonate test, where the ethanol is not going to react, but ethanoic acid surely going to react because it shows certain bubbles when it react with sodium hydrogen carbonate. Why does micelle formation takes place when soap is added to water? Because it gets easily dissolved to the water, and other solvents does not get dissolved. That is why it doesn't happen in other solvents. Why are carbon and its compound used as fuel? Because of the complete combustion which is only can happen in the carbon as a fuel, which means alcohol. Okay, alcohol is being used as the fuel. Okay, explain the formation of scum when hard water is treated with a soap. We have already discussed the major steps. You can go through the video once more and you can get the answer. What change will you observe if you test soap with litmus paper? Obviously, soap is a basic one. So, its pH level comes under the base. So, it's a base. Soap is a base. So, it will change the red litmus blue and blue will remain the same. Now, we'll talk about what is hydrogenation and what is its industrial application. We have already studied about it. Yet, hydrogenation is one of the part of addition reaction which can change the unsaturated hydrocarbons to the saturated hydrocarbons. For knowing the industrial application, I have already discussed in part 2. You can go and check the video. Which of the following hydrocarbons undergo the addition reactions? All the unsaturated hydrocarbon goes through addition reactions because these reactions help in turning out the unsaturated hydrocarbons to saturated hydrocarbons. Means the double and triple bonds are being break to form what? Single bond hydrocarbons. Which of the following hydrocarbons undergo the addition reactions? So these are the answers, C3H6 and C2H2, because they form the double bond and that is why they are unsaturated hydrocarbons. So obviously they go through addition reactions. Give a test that can be used to differentiate between saturated and unsaturated hydrocarbons. So the only one test is the bromine water test. So this water test, bromine is in red brown in color. So whenever the bromine water test is undergo or goes through the saturated hydrocarbons, it does not show any change. But when it goes through unsaturated hydrocarbons, it get decolorized. So red brown color get decolorized. Okay. And explain the mechanism of the cleaning action of soap. So it is obviously that it forms a micelles and emulsion is being formed. Already we have discussed the steps. You can go through the part. Alright, so we have completed the U chapter, carbon and its compounds already. If you have any sort of doubts, just comment down below and go through the video for revising the whole chapter. And we will meet in the next video with the next chapter. Till then, keep on learning and keep on revising. Bye-bye.